Quadratic inequalities. So starting off with kind of a simple one here. Get x by itself just like you normally would. Take a square root of both sides, but when you do that, you got to keep in mind x could be positive or x could be negative, right? So it's kind of like thinking about the absolute value problems you've probably already done. So x could be, when you take a square root of both sides, x could be greater than 1 or x could be less than negative 1. Okay, because when you take a square root, if this is an equation, you'd say x equals 1 or x equals negative 1. But when you take a square root and you consider the negative options, then less is more, because the further you go back in the negatives, the number's technically getting smaller, but squaring it will bring it back into positive land. So in other words, you take a square root to finish solving, get x is greater than 1, and then you also have to consider the negative answer. So that means you also have to switch the inequality symbol. So in interval notation, it means negative. I'm looking at this one here. This is as small as we can go in our solution. You can go to negative infinity, but then you got to stop when you get to negative 1, union positive 1 to positive infinity. That one looks like our guy. Let's see what else we got. Ooh, this one looks like fun. Okay, so we got x squared plus 3x minus 18 over x minus 7. We want to make sure we note before we try to say our answer that x cannot be 7, whatever we do, because that would cause us to have a divide by 0 error. Actually, this is, let me see, factor the top. No, okay. You can multiply both sides by x minus 7, right? Perfectly legal thing to do with math. That makes this cancel out, and then x minus 7 times 0 is just 0. So now it's quadratic. So let's see if we can factor this. Two numbers that multiply by negative 18 but add up to be 3. How about positive 6 and negative 3? That multiplies to be negative 18. Oh, not squared, right? That multiplies to be negative 18, and that adds up to be positive 3. So there's two solutions when you set this, when you set these aside. X could be, negative 6. If we were to solve this as an equation, x could be negative 6 and x could be 3. Because it's a rational equation, because it's quadratic though, you might want to check to see if it switches directions at these places, okay? So like if you test the number like negative 7, and then let's test the number between these two, x equals 0, and then test the number to the right of this endpoint, x equals 4 maybe. Okay, let's see what we're getting. Because being greater than 0 means we should be getting positive values, right? So if you plug negative 7 back into this whole thing, the top becomes 49 subtracted by... If you plug in negative 7 into the left side, you get 49 subtracted by 21, and then subtracted by the 18. We get a positive 10 divided by a negative 14. That's negative. So our solution shouldn't be on this side, right? It should not be less than negative 6. We just tested the point of less than negative 6, didn't work. Now if you test the point x equals 0, the top becomes negative 18, the bottom becomes negative 7. That's positive, so that's greater than 0. Okay? And so if you test the point to the right of x equals 3, like x equals 4, you get in the numerator 16 plus 12 subtracted by 18, you get a positive 10 divided by a negative 4. That doesn't work. So our solution is between these two. Okay, so solve it like you would a quadratic, but then check to the left, in between, and to the right. And when you do that, we just checked and we saw brackets. That negative 6, between negative 6 and 3 is where it's positive, where it's greater than 0. Oh, can we combine these? It's got 2. That makes me think I did something wrong, though. because it's got two different things. Maybe I dropped something or a negative sign. Let's just check that real quick. If you graph it, it's not really the mathy way of solving it, but gets the job done. Yeah, we're right. Between -6 and 3, it's positive. It's above 0, right? So let's see how to make Newton do this. Closed dot, right? I don't know which one's closed dot. Oh, that's open. So let's close dot. Okay, that's what we want. And I think Newton wants you to... Can't make these cross, huh? Just need to get rid of one of those because we got the solution, but it's got two different lines there. -6 and 3 is what we said, so that should go here. And that's a closed dot, so that's all good. Now we just need this to disappear. You think we can? No, it won't let us. Go away. I don't know. Let me just drag it out. Get out of here. We don't want you. No. I'm not crazy, right? That's the solution. No, it's Facebook. You don't want to look at my Facebook. Here's the left side. The problem we're working on. X squared minus 18. X minus 7. We want to find out where it's greater than 0, so we want to find out where it's positive. I did miss something. I must have plugged in 4 wrong. Okay, so it's greater than 0 between, what do we say? -6 and 3. Where is it? And then we plugged in x equals 4. We shouldn't have had any other. Oh, after -7, because -7 was a 0. Okay, yeah, that's a big mistake on my part. We said at the beginning x could not be -7. That's another place where it could switch directions. X, yeah, not -7, sorry, x equals +7. So we tested x equals 4. It's not going to work in between here, but if you test x equals 8, I bet it's going to work. Yeah, because if you plug in 8, the top becomes 64. That's definitely going to be bigger than 0, and that's bigger than 0. Bigger than 0. That's not negative, so that's also positive. So that's one big thing I missed. So I'm sorry about that. But if you have something in the denominator, like x equals 7, and that makes it be 0, that's a third place you have to check. Where you solve and where it could equal 0. Those are places where the graph could switch directions, okay? So x equals 8, everything, x equals 8 worked out, so everything beyond x equals 7 also works, okay? But we want to make sure we don't include 7 because we said that wasn't part of the solution. Okay, so we got to make sure 7's an open dot, and then that's going to infinity like we wanted. Okay.